Welcome to AW Services YouTube channel.
Welcome to AW Services, just a short video which will be a part of a series of videos. I've got myself an Armtec plastic ammunition box. It isn't classed as a 50 cal box, it's classed as a 233, is it? Or in British, NATO 5.56mm equivalent, or 9mm ammo box that I purchased on Amazon. Very good quality, very robust. What I'm going to do with that is make that into a leisure battery camping pack for when I go camping. You're out and about on the lakes trying to catch carp and you wanted a power pack to charge your phone off of, maybe your GoPro cameras if you're out and about doing an activity. You could also have a USB, cigar lighter style plug output, and a switch panel which will be along the front. But I'm just utilising this nice box, brand new. I thought, I want to make a power bank. Why buy one when I can actually make one? Drilled into the front of my box. I've put a 16mm 2-pin aviation style plug in there. Very similar to what us old folk used to have during the 90s in our CB radio microphones. But this is a 2-pole pin. So that would be my positive and negative charging port, which is fully sealed and waterproof with a waterproof cover. Drilled through the front, and then on the inside of the box, got the bulkhead nut on there, soldered on my battery charging cables. Lovely bit of heat shrink as well for insulation. And the battery, which is a 12 volt, 12 amp hour sealed lead acid U-cell battery, which I believe is part of the Uracer family. That will Velcro in there. And then once that's Velcroed, it's firm, it doesn't rattle around, but I will make an infill with some black high density foam just to pad out the sides from where the battery are. And then I will measure out with masking tape and do my markings for where my panel is going to fit under that top lip, which will have a 12 volt accessory socket, a 2.1 amp double USB socket, a battery voltmeter, and a mains battery master switch. That's all I need. Very basic, but it will serve the purpose. So I've put the battery, that's a 12 volt 12 amp hour U-cell lead acid battery. That is Velcroed with some 50mm very thick density Velcro. I picked that up from B&M. I think it was about £2 on special. I've used miles of it. It's brilliant. So the battery is stuck down with 3M Velcro, very thick pile Velcro, so it's very fluffy. And then I wanted to get some foam infills just to stop the battery moving, even though the Velcro holds it, just to stop a little lateral wobble that the battery had. I used to have an awful lot of very high density black foam, and this was found in professional DJ audio equipment flight cases, and you cut it to shape. Not your soft pick and pluck foam, but really hard, like a rubbery foam. I wanted some quickly, I wanted some now, but I did realise a couple of weeks back I went to Poundland and bought a few packs of these Hanon sponge sanding block pads, and there was a pack of 4. I bought 2 packs. I put them on my chopping board, which I use for my soldering, with a very sharp old carving knife that I sharpened up and actually cut the edges off, so all of the abrasive sanding material is gone, and I'm left with exactly the same type of black foam that I wanted. Blocks, and I hot glue gunned the blocks together, and I pushed them in the box, and when I wobble the box, the battery does not move. So the battery's in, my 12 volt 16mm charging socket is in the front of the box, and tomorrow I'll mark out and then fix my 12 volt panel with my double USB charging ports, battery master isolator switch, battery level indicator or voltage display, and 12 volt accessory socket. And it'll all go in this box. The battery is a valve battery, so the battery doesn't need to vent, so it'll be completely sealed. And then once all the wiring's in place, I can hide all the wiring. I can put another layer of foam on top of it all, and then I can put in USB charging leads and a few bits and bobs that I wanted to store in the top. But the overall project for me has cost me pretty much next to nothing because I already had the parts. I'll put a list of parts and pieces together at the end of the video if anybody's interested. Very easy, basic skills required. So it's now time to fit our electronics. So there's the box, masking tape on the front of it, panel template, I'm going to align that by eye. A bit of gaffer tape to hold that in place. It's not going to move. Nice pencil. I'm now going to mark out the fixing centres. I'm going to draw around our cutouts. Just going to find the center of my circles. Doesn't have to be precise. Just some tape to catch any swarf debris. .43mm. So just double checking our measurements. Plenty of space. I'm now going to proceed to pilot drill the centres of our holes. Okay, I'll just explain something for context. This is the Amazon switch panel kit. I will put a description and maybe an inlay on screen now. This is a panel kit. As it comes, it has a bulkhead nut on the back. So in the illustration and the way that you're probably intended to fit it is like so, and then pushing that into the box. But because of the bulkhead nut on the back is taking up most of that surface area, you don't need it. So if you're using these in a boat, a camper, or like my installation, instead of doing that, just drill the whole center out, push that through, and because of the box thickness, I'll then put the bulkhead nut on the back, and I'm using that really for aesthetics because it looks nice and it also is a strengthener, if that makes sense. So I'll put that back in there. So our hole size that we require is 28.5mm. So this step drill goes up to 20mm, just to see I'm not drilling any lower than I should be. I'll take up the excess. The only thing is, if you struggle to find the centre or the circle, you may be off. it isn't crucial in this because you can actually ream it out as well, or you can actually use a reaming tool, deburring tool. So this is a basic deburring tool with a sharp hooked carbon steel blade. You turn it round in a circle and it'll take out any excess material for you. Always good to have something to hand just to ensure that you aren't over drilling, because once you've drilled a hole that's too big, you can't put that material back in it. So larger step drill goes up to 32 millimeters. Again, there's the bulkhead nut. So I'm going up to the black mark. Quite convenient because I've used it before. So you've got a step drill, get yourself a Sharpie, just as a safety line. And if you want to, if you're not sure, better to measure twice and cut once, or measure 1,000,000 times and still cut it once. That just gives you a reference mark. Haven't got to go gun crazy. Just keep test fitting to make sure you're not too big or oversized. So that one there, we're nearly on it. So with my deburring tool I can cut out millimeters at a time. Don't want it sloppy, just want it nice and tight. Happy with that one. Now proceed on to the next one. Okay, I'm back. Just thought I'd share something, because if you're trying to follow along and copy this build, and you look on Amazon, you won't find any kind of circuit diagram, because this kind of installation varies on how you want to wire it up. It will come supplied with some short cable, with some fuse holders. To me, that's all junk. I never use things that come supplied. I always use my own cable, the correct gauge wiring, the correct insulation values, and then it doesn't melt and go bang because it's pure Chinesium. So I've already in advance drawn a circuit diagram which I can share with you all. Right, now I'm just going to wire up. Before I do anything else, I'm going to wire my charging socket directly to the battery. That's so you don't ever make any mistakes, that when you wire your charging socket in, if you want to do it like mine, some of you may wish to use crocodile alligator clips directly onto the battery. Not always the safest way. But then if you wire your charging socket directly to the battery, and then you take your power from your battery to your switch, when you go to charge your unit and your battery, it won't be affected by the switch on the front. So when you're charging it, nothing's going to light up, you're just charging it. And I'm using a dedicated sealed lead acid battery charger for this project as well. So I need to get power from the battery to the main master switch. So I'm just taking two other pieces of cable, wire, flex, cord, wherever you are in the world, whatever you fancy calling it. And they're going to piggyback into the same wires as the charging port connection. So I've then got almost like a Y cable, so I can take the battery from the port, from the charging port straight to the battery, and then come off of the battery to the oh, my brain's gone dead. From the battery then straight to the fuse. Always good to use a fuse. I'm just looking for some colour-coded heat shrink. This video is made on the fly and I will edit it together. Colour-coded heat shrink. All I'm doing with that is just putting 2 pieces on my blue push-on female spade connectors to denote positive and negative on the battery. So I'm just going to cut 2 pieces of that to length. Ba-da-ba-ba. Still bunged up with the cold, can't breathe, can't talk. Guess a lot of you are like, oh yes, thank God for that. You shut up for once. Heat shrink's brilliant. It covers your work up and gives a secondary layer of insulation. Even though the blue female spade connectors are insulated, I'm using this even though I'm using colour-coded cable, because I pride myself on my work. It looks tidy, but also it helps with the polarity of things. Polarity means something can only be used one way and connected one way to function in a circuit. If you get that wrong and your polarity is incorrect, especially with an LED where you have an anode and a cathode, it will not illuminate. So phase, polarity is important. Always do a pull test to make sure your terminals don't fall off in your hand, but I'm using the correctly set up automatic crimper, so the pressure that it applies is exact to meet the size of the connectors that I'm using. I'm lucky as I can get 2 conductors in one plug and push it all in firmly like so. You can, when you watch this video, you can actually zoom in by pinching on the screen on YouTube, and you'll be able to see this at a better resolution close up. So I've got red and black. Just going to get my Bosch hairdryer. Just want to create a heat shield. Normally goes wrong like this. There we go. Couple 100 degrees. Yeah. Tasty. To one side. So my battery connectors now are insulated again, and they will go onto the battery like so, and then I've got the wires here that come off of that, and then they will go to the point of the switch. So they will go like that. I need to have just measure them out just to make sure that I've got the correct lengths that I need. And make sure this is all tidy when I've done it then. To the cut those to length. Now the wires here, so I've got charging connection in the box, which is for my charger. They go to the 2 terminals, which are then the battery terminals. I've piggybacked off of those terminals then to supply a positive and negative supply to my switch. These are some really good American cable strippers. I've had these now for about 25 years. Used to have an apprentice electrician working for me, and he one day left these behind and they were brand new, so it's like goodbye to him and hello to me. Always twist your conductors to make sure that they don't fray out, and then you won't get any short circuits or arcing because you've poorly prepared your wiring. Spay terminals, these I bought quite some years ago now. Bought these on Amazon, but they're very good quality. These are GTSE. There was 100 blue spay terminals. Blue is 6.3 millimeters. So polarity wise, doesn't really matter with the plugs here. I haven't got to put any more heat shrink on them because my cable conductors are polarity correct. Red is positive, black is negative. That's all you need to worry about. Always double check your connectors are tight, they're not going to fall out. Always ensure that you've got all of the copper inside the connector so it's not going to short anything. So battery, charging circuit, 2 terminals to the battery, and then battery to switch. So on the switch, I didn't realise with this kit it actually comes with a 3-pole switch because it has an LED that lights it up. So your ground or your negative on the switch on this one is actually your gold or copper coloured pin. Your middle pin is power, that's battery, and then the top pin is your output, which is your load, and it's your load that actually turns everything on, if that makes sense. Right, just gonna, now I'm gonna, because I forgot to do something because I was chatting. Men cannot multitask, which is very true. So then on these wires, it might seem a bit excessive. I now then need to put on 2 more wires to that, because what I'm doing is creating a constant ground or a constant negative line which goes across the negative or the common connectors of all of these, and then the positive, because it goes to the switch, then piggybacks off the back of each one. So when I turn the switch on and the switch has power and it's energized, then everything is going to come on. So I'll just do a recap 1 second. Okay, so because I'm using because I've got 2 connectors that are coming out the same plug, all I'm doing is just putting a piece of clear heat shrink on the back of that, just so that when I push it in the plug, all that's doing is keeping these 2 crimped wires in the connector, but then there's no wiggle room or for any error that the wire can come up the back end of them. I like to make sure, because this project is going to be a robust, very robust design. You know, it has to endure boring camping trips with myself, so I want to make sure that it's built to last, and it serves its purpose basically. Just making sure I've got the right side connector, yes. So I'm getting a piece of clear heat shrink over my pair of negative wires. I'm twisting those together really tight. I'm now going to gently screw those into the terminal so they are tight, like so, and I'm going to crimp those. Okay, we're at the end of our build, so let me introduce you to the AW Ammo Bank, which is an ammunition box, ABS plastic converted into a power bank. So I'll give you a look inside. I'll move the camera in so it's going to jerk a little bit now. It's probably going to all go tits up. Okay, just having a few issues with the camera. So in the box, I'll point with my pointy pencil. Just going to remove a small piece of copper wire that I dropped in there. Okay, so our charging port on the outside comes in, red, black, positive, negative, and goes directly to my battery contacts. From the battery contacts, I've then got another black and red wire that comes out the back. So there's two wires, or two conductors, coming from those spade connectors, which take me straight to my main isolator switch. So on my switch, gold or copper on the switch is actually negative, ground. And then you've got a supply, which is the top pin, the same top as so the LED on the switch goes at the top of the switch. So the top wire coming in from our battery is our live, which goes all the way piggyback from the switch to the voltage display, from the voltage display to the LED, to the USB port, and then from the USB port to our 12-volt socket. 12-volt socket is actually marked positive as well, which is helpful, and the USB is also marked. So that's basically it. I'm going to make a cover that sits in there, so there's enough space then to put my charging cables. So I'll get a piece of foam and I'll sculpt it so it hides all of that. But there's still a bit of space in there. Its sole purpose is a power bank, so aesthetically it's not going to be something that's going to be winning any awards. However, it's very, very safe because I've made it. That's it all inside. Nothing rattles around, nothing's loose. I'm going to put a few cable ties on these wires and lace them together so there is no vibrational movement. There is my charging socket on the bottom, which is there. And then on the front, for the pièce de résistance, we have our main battery switch. So my battery is showing 12.3 volts. I've got a green LED to show me my power's on. That also lights up. I've got a 5-volt USB socket. I'll turn the video light off so it's not overexposing it. 2.1 amp twin USB socket, and also my accessory plug as well. But that's basically my camping power supply box. I can charge my phone. It's got a flat surface, so my phone will sit on top of that, and it's all there, it's all in one. And then from that I can run a LED light that works from USB, or I can put in a small spotlight from there. This battery and this actual box, I've got it at 3 amps maximum load, so 3 amps is massive. I'm going to put a 47 watt car LED spotlight on that, and it'll be absolutely fine. And I've also got a fuse from the battery before the switch as well. But that's pretty much it, you know. Doesn't she look beautiful? Drab olive green, a black contrasting front panel with green LED lights. But that is it. That is the AW ammo bank. If you like the video, if you have any questions at all, please subscribe, please support my channel. I want to help it grow more. Leave any comments that you have and I'll answer some questions. I'll add a list of what's in this kit in the description, along with the wiring diagrams and the images that you can zoom in on and pause. I hope you've enjoyed the video. A bit of extra content behind the scenes at the AW Skunk Works. Thank you very much for watching. Take care.